Hello students, in today's lecture we'll discuss about drops and bubbles. You might have noticed this thing that when water coming from a water tap, they take the shape of sphere when it hits the ground. From the water tap, a chain of water that is coming out from the tap, then when it hits the ground, then finally takes the shape of a sphere. That means only the small water droplets are spherical in nature. Those who are bigger, they are either deformed or get flattened shape. Even the raindrops, those are coming from the atmosphere, also spherical in nature. When they combine to form a bigger one, they get either flattened or get deformed. The soap bubbles that are coming out from toy guns, which almost we all have played in our childhood, the soap bubbles are also spherical in nature. So what is the reason behind that? Let's understand what is the reason why these small water droplets take the shape of a sphere. This is due to the property of the water known as surface tension. Surface tension is the property, that's why the free surface of the water behaves as a stretched membrane. So what does that mean? When water drops outer surface, molecules are present and water molecules are combined with each other with some force that is known as cohesive force. In case of what surface molecules, this cohesive force is acting in downward direction. Now for the water molecule, the surface force is the net surface force acts downward direction because the inner molecules, those are present in the inner portions. They were bounded by or they bonded from all over. So these molecules, they bonded from all over. So here it is in equilibrium. Now this molecule which is on the surface of the water, that's not bonded outside, means this portion there is no bonding. So here the net force is acting in the downward direction. So what happened, this tries to stretch the molecule in inward direction to acquire minimum surface area. This is the tendency of these surface molecules. Because they have high cohesive force of attractions, this force tend to pull the molecules in inward direction. So these molecules, they try to pull the molecules in inward directions. So because of that, this becomes little bit stretched and they take the form of a sphere to acquire minimum surface area. Why? Because for a given volume, the sphere has the least area. Sphere has least area for a given volume. The sphere has least area. So, to acquire minimum surface energy, they tend to take the shape of a sphere, and this downward force try to pull these molecules in inward direction so that they will get stretched inwardly, so it takes the shape of a sphere. So in this process it acquires a excess pressure than the outside pressure. So always inside a water drop or soap bubble, the pressure inside is higher than the pressure outside. Let's suppose this inside pressure is delta P. It's higher by a very small amount. So let's this excess pressure is delta P. Now how this delta P is related with the surface tension? We are going to prove that mathematically. Remember that not for all the drops this molecules are spherical. It has a threshold radius measurement. For certain value of radius it is spherical. The threshold value is almost near about 3 millimeter. Up to that range it take the shape of the sphere. Then after that gravitational force. When it is going downward direction, then gravity is also there, then air resistance is also there. But when it is very small, within the range of threshold radius, at that time this surface energy is dominating. So it takes the shape of a sphere. When it is become when the radius is become greater than that threshold value, then that time gravitational force and air resistance that plays a dominating role. So that's why it gets flattened. So now let's calculate how to find out the extra pressure inside a water drop or soap bubble. Now let's think that due to this extra pressure, the surface area increases slightly. That means let's suppose the radius r is now become r plus dr. So this increase of radius is dr. Okay. Now what is the work done? Mechanically we can say that to pull a sphere up to a radius dr, work done W is equals to force multiplied with displacement. Here the displacement is the amount of increase in radius. So that is equals to dr. So force in terms of pressure we can write that is delta P. This is behind this increase of area. So we'll write in terms of extra pressure. So here the pressure is delta P multiplied with area. Area it acts on to increase it. So that is area of this smaller circle multiplied with dr. So what is the area of the, I am writing here S to represent the smaller circle. So what is the area of this smaller circle? That is 4 pi r square. Since it is a sphere, so this is equation number 1. Suppose this is equation number 1. Now again this work done is stored as potential energy. Here in this case we can say that the work done is stored as its surface energy. So let's calculate the surface energy. We know that what is the surface energy? That is equals to surface tension. That is equals to surface tension multiplied with increase in area delta A. So here the surface tension of water is T and the increase in area is delta A suppose. Now let's calculate the increase in area delta A. So what is the amount of area increase? Area of the bigger surface minus the area of the smaller one. So what is the area of the bigger surface? That is equals to 4 pi radius square. Here the radius is r plus dr whole square, area of the bigger circle minus the area of the smaller one, which is equals to 4 pi r square. 4 pi r square. So now by opening this, I'll get r square plus dr square plus 2r dr minus 4 pi r square. So here when I'll open this one, so 4 pi r square, 4 pi square will get cancelled. So finally we'll left with 4 pi dr square plus 8 pi r dr. So this is the amount of area increased. Now this dr value, the increase in radius, that is very very small. It's not even visible to the normal person, but it increases. So this when this dr value is very very small, suppose it is 0.201 or 0.05, then its square if you do, then it even gives you a very negligible value. So this term we can say can be neglected. So finally the increase in area is equals to 8 pi r dr. Finally the increase of area is 8 pi r dr. So this value I am putting here, surface tension multiplied with 8 pi r dr. Now work done is same as the stored surface energy. So that is equals to the equation 1 can be equal to equation 2. So by equating equation 1 and 2, we will get del P 4 pi r square dr is equals to T 8 pi r dr. So here dr get cancelled, and this 4 pi 8 pi will get 2, and r square get cancelled. So we will only left with pressure term, that is the excess pressure inside the water drop or air bubble, that is equals to delta P. This is 2T. From this side only R is left. So this is equals to R. So delta P, how this excess pressure related with the surface tension and radius of the sphere. This delta P is related like this. 2 twice of T upon R. Now for soap bubble. For air bubble, this is the value, but for soap bubble, there are two surfaces. For soap bubble, there are two surfaces. How soap bubbles are formed? There is air inside, here water, and then again here air. So there are two interface, air water interface and again water air interface. Okay, this is how your soap bubble is formed. So we will take 2 surface area. So that's why again this term will increases by 2. So here delta P is equals to 2 into 2T by R, that is equals to excess pressure inside a soap bubble. Air bubble twice T of R. Soap bubble will be 4T upon R. So this is how pressure inside a drops or bubbles related with its surface tension. I am again saying that for a threshold value of radius, you will get spherical shape where gravities or gravitational force is neglected. When water drops become bigger, their gravitational force plays a dominating role. So again those get deformed. So you may not get these relations. You will not get a spherical water droplets. This is only for small droplets and your radius value is within certain range. Okay, this is all about water drops and bubbles. Hopes you'll get understand. If you have any doubt regarding this topic or any other topic, you can feel free to write in the comment section. Thank you for watching Physics Tutor. Keep watching it regularly.